2014, and I want to welcome you here to this integration tier. The integration tier is something that's still relatively new with the new event model and the forums. It's intended to bridge the gap between the plenary sessions and the technical sessions and provide material and dialogue and conversation to bridge that gap, to hopefully appeal to both the traditional attendee but also to draw in other aerospace professionals who don't maybe typically come to AIAA, even though they may be members, or maybe they're not members. We have 9 of these integration sessions set up. They run at 9:30 each morning and 2 o'clock each afternoon, except for Friday afternoon. They'll all be in this room. I'm going to get off the stage now and let the first session get started. I want to introduce Steve Justice, who's the director for the Center for Innovation for Aerospace in Georgia. Thanks, Steve.
All right, thank you. Thank you. Well, before we start the panel today, I want to do a little administrative thing. This is a panel. This is not a plenary speech, so this is an interactive activity. So we're going to have our speakers each give about a 10-minute introductory commentary on what they think about the challenges and opportunities that are facing us in aviation. Then we're going to have some questions that I will pose to them, but most importantly, we want to get your questions. We want this to be an interactive panel today. So we have a mic set up in the middle there. We just ask that if you have a question, please step up to the mic. We will recognize you, ask your question, and hopefully we can answer that question. As Rich said, I'm the director of the Georgia Center of Innovation for Aerospace, and that is a program of the Georgia Department of Economic Development. And really our goal is to work with companies within the state to give them access to industry expertise, university research, potential business collaborators, a qualified workforce, and current industry information. Now, why is that important? Well, in Georgia, we have a very long history in aviation and aerospace. Let's take you back to 1907, when a young Ben Epps, 19-year-old young man living in Athens, Georgia, he flew, the family says that's a euphemism, but he flew an airplane of his own design and fabrication in October of that year, less than 4 years after the Wright brothers in their first flight. It was his own original design, a monoplane, which, as many of you probably know, that was somewhat unique in that time period. Now, the Epps family from that point became the leaders of aviation in the state. The Epps Flying Field in Athens was our first commercial airport in the state of Georgia. And Epps Aviation still exists today and was our leading aviation companies in the state of Georgia. Well, let's fast forward a little bit. Through the 20s and the 30s, aviation continued to grow in this state. But as we entered the 1940s, there were 2 major events that occurred that really shaped the future of aviation in this state. In 1941, Delta Air Service, which later became known as Delta Airlines, moved its headquarters from Louisiana to Atlanta, really solidifying Atlanta as the aviation hub for the Southeast. Now, they continued to grow, and as we get into the 1960s, Delta was one of the first adopters and very strong adopters of jet aircraft in the National Airspace System, and Atlanta built one of the first new terminals in the early 1960s tailored to jet aircraft. And Delta built their first maintenance facility for jets, which we called for many years the Jet Base. I think many of us still do. And if you've been to Atlanta Airport, you've seen that jet base. When you see the Fly Delta jets up there in neon lights, that is the original jet base, which of course looks very small in comparison to some of the facilities they have today. And together, Delta and Atlanta Airport grew until now, of course, it is the busiest passenger airport in the world and the busiest airline hub in the world. The second event that happened in the 1940s that really shaped aviation in this state was the federal government came down to the Deep South and built Air Force Plant Number 6 in Marietta, Georgia. You heard a little bit about it during the opening speech today. That was the first major aircraft production facility in the Deep South. It was operated initially by Bell Aircraft, building the most advanced aircraft in the world at that time, the B-29 bomber, building almost 700 of those aircraft here in Georgia. After the war, the plant closed, and in 1951, Lockheed came in and took over that plant to refurbish B-29s for the Korean War and later build B-47 Stratojets. Yes, we built B-47s here in Georgia. After that, Lockheed began building their own designs there, aircraft such as the C-130 you heard about, the C-141 Starlifter, the C-5 Galaxy, the Jetstar business jet was built here, P-3 Orions, the F-22 Raptor, and of course now supporting the C-5M and the F-35 Lightning II. So those two events really shaped what was to happen over the next 50, 60 years here in the state. So it was really fitting that today, to this opening panel of Aviation 2014 here in Atlanta, we have representatives from those two anchor companies for our aviation business in Georgia. Aviation in Georgia is very big in aerospace. We have over 700 companies in the state that are involved in aerospace and aviation. Aerospace products are the #1 international export of the state of Georgia. You've heard about our airport. We're very strong in air transportation, and we're very strong in the maintenance, repair, and overhaul of aircraft, both on the civil side and the military side, with a major facility in Warner Robins, Georgia. So it is my pleasure to introduce our first panelist for today. And we'll start since 1941, Trump's 1951. We'll start with Delta. Captain Steve Dickson is a Senior Vice President of Flight Operations for Delta Airlines, overseeing Delta's day-to-day flight operations, as well as pilot training, pilot standards, technical support, pilot staffing and scheduling, and quality assurance compliance functions. He also provides leadership and direction to Delta's 12,000-plus strong pilot group. He's an 18-year Delta veteran, served as Special Assignment Supervisor, Manager, Pilot Crew Scheduling, Manager Strategic Planning and Communications, Assistant Chief Pilot Atlanta, and General Manager for Flight Operations. In 2005, he was promoted to Director of Flight Operations and assumed his current responsibilities in September 2006. He is also currently qualified as a 757, 767 captain and has also flown the 727 and 737 over his career at Delta. He's a former Air Force officer and F-15 fighter pilot, also a distinguished graduate of the United States Air Force Academy and a cum laude graduate of the Georgia State University College of Law, and lives in my neck of the woods in Fayetteville, Georgia. So please welcome Captain Steve Dickson.
Thanks, Steve. Thank you, Steve, and thanks to AIAA for your hospitality and your invitation. You know, obviously Atlanta and Georgia are a huge part of Delta Airlines. We're the largest employer in the state. 25,000 of our 75,000 employees are based in Georgia, with a huge concentration here at the airport, obviously, at our largest hub here in Atlanta. I do have to apologize. I didn't realize that's a little bit of an outdated biography. I've actually been with Delta for 24 years, and currently am a captain on the A319, A320. And after the acquisition of Northwest Airlines a few years ago, our fleet became a good bit more diverse than it had been previously. And we operate currently a fleet of 741 aircraft, getting larger by the day, with a number of 737 aircraft being delivered every month, and the Boeing 717 as well. We also have a number of aircraft from Airbus on order as well, with another 45 A321s and 10 A330 aircraft due to be delivered within the next 3 to 5 years. So it really is great to be here. And as Steve said, our roots in Atlanta go back to 1941, but our roots in Georgia actually go back to 1926, because if you're not aware, Georgia, or Delta actually, was the first commercial crop dusting company, founded in Macon in 1926, and then within a couple of years moved its headquarters to Monroe, Louisiana. So in some respects, we owe our existence to the Bull Weevil. But we had our first passenger air flight. Actually, we'll be celebrating 85 years since our first passenger flight tomorrow with the dedication of the Delta Flight Museum, which will be open to the public down at our headquarters spaces just north of Hartsfield International Airport. So we're really proud of that. 73 years in Atlanta. Our fleet types currently consist of the 747, the 777, the A330, and several models of the 767, both the 767-400 and the 767-300. Some of those, most of those 767-300s are transoceanic capable, although we do have about 12 of the airplanes flying in our domestic system. For our domestic aircraft, primarily the 757, 3 models of the 737, the 700, 800, and 900, the A319, A320, also the same aircraft type, but a larger version, the A321. As I said earlier, we have a number of those on firm order, as well as 182 MD-80 and MD-90 aircraft, which were originally manufactured by McDonnell Douglas, and then the 717, which started its existence as the MD-95 before McDonnell Douglas and Boeing went through their merger. Our network, we have several hubs around the country. As you're well aware, Delta was a pioneer in the establishment of the hub and spoke system decades ago, and I think it really dovetails well with Atlanta's history as a center of commerce and really a leader in all sorts of network industries, all the way back to the railroads, which was certainly a chief reason for Sherman's march on Atlanta during the Civil War. But then, of course, the establishment of the interstate highway system, the tremendous road network that we have, and then also really as Delta and Hartsfield-Jackson Airport have developed hand in hand over the years, establishing the largest airline hub anywhere in the world here in Atlanta. We also have hubs in New York City, JFK, one of our largest international Atlantic gateways, and we established a hub at LaGuardia Airport a couple of years ago. We also have large hub operations in Detroit, Minneapolis, St. Paul, Salt Lake City, Cincinnati, Los Angeles, and Seattle, and then significant international hub operations at Narita, Japan, Amsterdam, Charles de Gaulle near Paris, and of course London Heathrow. Having said all of that, Delta's somewhat unique compared to some of the other network carriers in that we have a very large concentration of our network here in Atlanta. And that's a tremendous benefit, I think, for certainly for the regional economy and really for the economy up and down the east coast of the U.S. About 35 to 40% of the operation is actually concentrated in Atlanta. So that's a little bit different from some of the other network carriers that are a little bit more evenly dispersed around the system. Actually, our operations in Atlanta on a daily basis outnumber the operations at our next 6 largest hubs. So it's a huge hub here at Hartsfield Airport. In my area in flight operations, Steve hit the high points. Of course, our highest priority is safety, and so I am part of the senior operations team that manages safe and efficient operations of 2,800 to 3,000 flights a day on our mainline operations. I supervise and execute the operations working with 8 chief pilots around the system, our pilot domiciles. I also run our flight training operation. We have 28 full flight simulators at our campus just south of here, and we're running around the clock training pilots for our needs, and we're going through a tremendous pilot hiring cycle right now, and so we're bringing on really our next generation of Delta pilots at the rate of about 50 pilots per month that we're putting through training. So tremendous growth, and we're also in a pretty big retirement cycle right now here over the next decade or so, where we'll be seeing a good bit of advancement for our younger pilots, as well as pilots who are reaching the retirement age of their career. In addition to flight training and simulator maintenance, I'm responsible for flight standards, which is our quality control out in our line operation, and regulatory compliance on the operations side, and of course pilot selection and hiring, which I referred to a minute ago. And finally, as one of the largest airlines in the world and one of the 3 big network carriers, we feel an obligation to be an industry leader in innovation and in the development of technology. And this covers several different areas. The area that I'd like to focus on, and I know that we're going to take up at some point probably during the panel, and also I know that you've got some speakers later in the week who are going to talk about the air traffic control system and NextGen in particular. And I'm actually the co-chair of the NextGen Advisory Committee working subcommittee, which works closely with the FAA, with the Deputy Administrator Mike Whitaker and Ed Bolton, the Associate Administrator for NextGen in Washington. And the air traffic control system in the United States is the finest system in the world. But it is a legacy system that's based on a paradigm that really dates back to the 1950s. And it has been, the performance has been improved and new tools have been developed, but we are undergoing a transition now to transform that system so that we can take advantage of technologies that allow us to share information, make smarter decisions in real time, and control aircraft really from gate to gate and even before the flight departs the gate by exchanging data and making informed decisions between the operators and the FAA. So, you know, this is a huge undertaking, and it's really much more than a series of tools in terms of improved technology that are being implemented. For example, one of the tools that's being implemented is data communications, which is sort of like the aviation version of text messaging, so that pilots, instead of communicating with air traffic control via the radio, as we have done for decades, some of those transactions, and this has been going on for a number of years in the oceanic environment, but some of those transactions are going to start occurring through the exchange of textual information, which should improve the efficiency of the operation over time. Of course, the introduction of GPS for more precise navigation and surveillance is a big part of NextGen as well. But what we're working very closely with the FAA on, however, is how do we use those tools and how do we implement them on top of a legacy system that needs to continue to operate safely and needs to continue to serve the traveling public efficiently. And this is something that really requires, again, a tremendous amount of change management within very large organizations, and it requires many elements to implement, changes in regulations, changes in procedures that controllers and pilots have been using, and in many cases a change in paradigm that's going to change the way that we operate, that we have operated for decades. So we have seen some timeline delays and some implementation barriers. Although NextGen is a change to the system, most of the benefits that operators and ultimately the traveling public will see in terms of reduced flight times and more reliable schedules, those are things that we can measure now, and we want to make sure that those measurements do not deteriorate and that they actually ultimately improve once the new system is in place. And that's proven to be quite a bit of a challenge, particularly east of the Mississippi and up in the Northeast, where there aren't new airports being built, there aren't new runways being put in place, and it's an extremely congested airspace, and that part of the country tends to affect the performance of the entire system. But it has proven over the last 4 or 5 years in particular to be very important to stay the course on implementation, because that's the only way that we've been able to identify some hidden inefficiencies in the system. As we take constraints out of the system, we're able to identify other constraints that have actually proven to be barriers to improvement. We've also been able to identify a good number of unforeseen coordination and command and control issues, coordination between air traffic control facilities, and as we've implemented, again, individual tools like performance-based navigation, that's highlighted some other waste within the system. Another issue that we have to deal with is, as much as we would like to think that all of our airplanes are going to be completely homogeneous and that we're going to get to this nirvana of the avionics in the cockpit being completely interchangeable throughout all the fleets, we know that there are different manufacturers, there are different flight management system architectures, different computer systems for ground integrators, and so ultimately we have to have a system that can deal with mixed equipage and some level of variation in capability. It's not, you're not going to see someone with a Cessna 172 making the same kind of investment that a major airline might be making in its flight management systems. So we really have collaborated very closely with the FAA through the Next Gen Advisory Committee, and we've set some very clear priorities from industry back to the government to try to help the FAA focus resources and commitment on those areas where we think we can demonstrate the best improvement for the system to keep this transition going. So again, I appreciate the opportunity to be with you this morning. I look forward to the discussion. And as Steve said, hopefully it'll be interactive and this won't turn into three talking heads up here this morning. Thank you.
I wanted to touch on one thing that occurred to me while you were talking. You described a scenario where you have a large number of retirements that are going to happen in the near future.
Right.
At the same time that you have really a sea change in the technology that the pilots are using in terms of next gen, ADS-B, we talked about GPS, things like that. That would seem to me that presents some unique challenges and maybe, again, opportunities to hit
Right.
the theme here of how do you deal with these two kind of contrary tides happening at the same time.
No, that's a great question, Steve. And it is a challenge, but I actually view it as an opportunity because if I look at how my children, who are all adults now, deal with learning about new technology, they're able to adapt in a way that maybe a generation that's more set in its ways has a little bit more difficulty doing. So we have actually, as we've brought in these new hire pilots, we are evolving our flight training programs to be able to certainly preserve the core skills that they need to have, but also leverage their ability to be able to process information maybe a little bit differently than a more experienced pilot, and so we're not really training some of those aspects quite the same way that we did before, and this will be something that we'll have to keep doing, looking at ways. For example, we found that for technical subjects, rather than instructor-led classroom training, many times distributed training with the availability to have the instructor actually during the training module when they're physically sitting in the flight simulator is much more effective in terms of the time spent and the ability to go back and learn some of these new technologies. And we're doing a little bit of we haven't gotten deep into social media yet, but we know that our classes tend to use social media. So since we know that they're setting up ways to connect with each other and network with each other as they're going through class and sharing information about their experiences, we're meeting them on their turf as well, and so we're incorporating some of that into our training programs.
Excellent. Not to forget our other panelist over here. I have to introduce him. Jack Chrysler is the Vice President for New Business for Air Mobility, Special Operations, and Maritime Systems at Lockheed Martin Aeronautics Company in Marietta, Georgia. His over 27 years at Lockheed Martin, he has served in various capacities, including International Vice President for Air Mobility Business, Director, International C-130 Programs, Business Development, and Director of Multi-Mission Maritime Aircraft Business Development. Jack received a Master's of Science in National Resource Strategy from the Industrial College of the Armed Forces of the National Defense University and a Bachelor of Arts in Journalism, Public Relations, Business Management from the University of Georgia. I give you Jack Chrysler.
Thanks, Steve. Well, I realize that being a Bulldog, I'm probably automatically in the minority, so. Thanks, Steve, for the introduction, and thanks to AIAA for hosting the event here in Atlanta. It's so much more pleasant to take a 30-minute drive from your home than spend half a day in airports, despite my loyalty to Delta Airlines. There's a couple of different perspectives on the podium today. Of course, my perspective is largely from an industrial base, defense focused in the production of aircraft that perform the mobility mission for both the U.S. government and our international customers alike. So, in that process, we're both based in aviation, and that's where our foundations are. But unlike the commercial business, ours is more focused on defense and specifically the U.S. government and DoD type programs. In that capacity, we have accountabilities to a similar group of people, and that's our employees, our shareholders, our customers certainly, and our community as well. So Steve gave you an outline of kind of the historical contribution that the Lockheed Martin facility, or Air Force Plant Number 6 in Marietta, has contributed to aviation history. We also play a big role in this community, and you think you're big until you share the stage with Delta Airlines. But we do employ 6,000 people at our facility here in Marietta, and we have employees living in 57 of the 159 counties, mostly in the metro Atlanta area, and we contribute about $1 billion annually to the local economy. So we're proud of our presence here in Georgia and in the Atlanta area, and we look forward to building aircraft in Marietta, Georgia, as Orlando said in his opening keynote this morning, for decades to come. So, we were asked to look at a couple of different items in our aviation industry, opportunities and challenges in the areas of business, technology, operations, and policy. So what I thought I would do is kind of give you a couple of examples of the things that I see as challenges and opportunities in those four areas, and that's in the spirit of trying to generate some dialogue about those topics and understand my perspective might be a little bit different than Steve's perspective. As I thought about this topic, obviously I looked through the lens of Lockheed Martin, but I also had to kind of see if my customer's perspective was aligned with mine, and roughly they are. They're worried about kind of the same things that we are in those broad four categories. But I would say that there's probably an alignment to a different set of words, and those, certainly affordability is one of them, and that's one of the things that we're primarily worried about. But operational agility, responsiveness, and technology infusion would probably be what you would hear from our customer. Unfortunately, with travel budgets for the U.S. government, there's not a whole lot of U.S. government counterparts in the audience or at the conference, but I think that's probably what you would hear. So I'll launch into kind of the four different areas, and I'll start with, from a business perspective, what I see as some opportunities and challenges. And the first would be aligning our discretionary budgets and how we invest our money with our customers' roadmaps going forward in the future. In an era of either flat or declining budgets, we have to be a lot more prudent with how we invest our money and where we make investments. So the opportunity to align our investment strategies with our customers' technology roadmaps is very important. It creates an efficiency that is probably a necessity at this point in time. Obviously, we're going to invest in other technologies and capabilities that give us competitive discriminators or capabilities where we can win business and beat the competition, both domestically and internationally. And then the other opportunity and challenge is kind of how we're running our budgeting process. And I don't think that continuing resolution after continuing resolution after continuing resolution is the way to gain efficiency. It certainly limits our ability to manage the planning horizon, and that inability to manage that planning horizon feeds down into the entire supply chain, down to small minority-owned disadvantaged businesses, and they don't have the resources and the capital to absorb those kind of delays and lack of certainty in the horizon there. So from a business perspective, those are the two things that kind of worry me. Operationally, either in the defense industry at least, either we're experiencing or you're going to experience some excess capacity. So you could utilize that excess capacity, either divest it and generate capital for other things, or you could utilize that excess capacity to entertain adjacencies or other markets that you may want to get into, including international business. And any international strategy as a growth engine is going to require you to really look closely at the business case analysis that accompanies those international opportunities, including how you source your bill of material. Because in our case, our largest customer, the U.S. government, their airplanes are built on the same production line as our international airplanes. If we make those decisions internationally, those components of the bill of material become a TINA compliant element of our proposals to the U.S. government. So you really have to evaluate that business case and make sure either strategically you're making a sourcing decision or competitively that's the best way to go. So, you know, as you start entertaining an international footprint, there's a lot of regulatory things that come with that. And I'm going to talk a little bit about ITAR, but I thought it was interesting. I was looking in the program this morning. There's a whole section about ITAR compliance in your briefings and ITAR permissions to participate in some of the technical discussions. So ITAR is one of the things that we really worry about, and that kind of manifests itself in the next section. Next part of the discussion is from a technology perspective, being able to transfer technology, manufacturing know-how, and engineering capability as a part of our business development process is a competitive discriminator, and in some cases it's a nationally legislated mandate for doing business in these countries. So even though we have restrictions and we have laws and regulations, excuse me, we have to go and address those in a smart way, and I'm going to talk about that in a little bit in terms of export reform is one of the other things. So our international counterparts are increasingly embracing an ITAR-free type of an approach to the market, which is a compelling argument, especially when you don't have to get permissions to utilize or exploit a technology. So that really leads to the next part, and that's policy. The two areas of policy that kind of worry me right now is export reform. I mean, the U.S. government gets it. They understand that a lot has changed since the establishment of the Export Control Act of the 70s and the Nixon Doctrine of the 60s. A lot of things have changed. I mean, there's peer capabilities out there, and there's technology and that are being produced OCONUS that rival our technology and capability as well. So the wisdom of restricting the ability to export those capabilities when they already exist out there in the world and they're proliferated is something that probably needs to be addressed. I said the U.S. government has, recognized the need to start reforming the export laws. You may recall when Secretary Gates introduced his 4 pillars, I think is what he called it. It was a 3-phased approach to look at both the munitions list and the commercial items list from state and commerce respectively, kind of homogenize those two lists and make sure that we were doing the right thing, protecting our technology and capability, but being a little bit more friendly in the export environment. And the other thing from a policy perspective that I see that probably deserves a discussion is advocacy for our national industrial strategy. And what I'm talking about there is if you look at our international competitors, that they are not hesitant about supporting their industry through bilateral defense agreements or even heads of state advocacy during international competitions. And now we have an advocacy center in the Department of Commerce, and you can apply for advocacy from the U.S. government if there's no other U.S. competitor that's participating in a competition. I would say that even though that exists and that is an appreciated capability, I would probably categorize that as kind of hit or miss in terms of the effectiveness of that advocacy. Sometimes it works very well, and sometimes it doesn't work very well, and there's a lot of political, military reasons for that, depending on where you're trying to compete. So those are the two areas from a policy perspective that I think represent some opportunities, but represent some challenges as well. So again, thanks to AIAA. I appreciate the opportunity to share our perspective, and I look forward to the dialogue.
One of the things I'd like to touch on is that you talked about budgets and the budget environment being, I guess we could say, unsettled. We'll give it that. The planning horizon is very difficult because you don't know what's going to be happening with budgets. On the other hand, Lockheed has always been viewed as a very technology-driven company. I think from all the way back to the early 1930s, Lockheed has been seen as a company that has brought new technologies to the marketplace through the various products. Given that legacy of technology, but the current environment of budgets, how do you, and declining defense budgets, how do you maintain your technology edge?
I think, Steve, that goes back to the importance of making sure that our discretionary investments through IRAD or how we go and win contracted research and development, how we work with the labs, how we align ourselves to roadmaps, not only keeps that technology edge at the forefront, it keeps it relevant because it is on the customer's roadmap, and it is giving us a technology or capability discriminator internationally as well. So it's a combination of attracting the right people and the talent that we have in our employee pool across the board drives kind of our innovation. And certainly that talent pool is what helps us execute our business plan. So without that influx of talent and innovation, I don't think we could do it the way we do it.
And to follow up on that, we see that the horizon between programs has gotten longer over the last 30 to 40 years. Lockheed now very involved in the production of the F-35, which looks to be, in many ways, the only fighter program for the next 20, 30 years. We don't know yet. What do you see on the horizon? What kind of opportunities may be out on the horizon for aeronautics? And do we see a shift within Lockheed between aeronautics, which has been a big part of the success of the whole Lockheed Martin enterprise, and the other parts of the enterprise, and your missiles and fire control, mission systems, space systems? Do we see that balance changing over the next decade or two?
I think what you're going to see, not only at Lockheed Martin, but at the other defense OEMs, is a heavier reliance on the international market out there. You'll also, I think, see a deeper focus on MRO type of capabilities, not only maintaining and refurbishing and overhauling equipment, but modifying that equipment to perform other missions and introduce technologies that enable other capabilities, kind of expanding the footprint of those things that do exist already. And you may recall operational flexibility and adaptability from our customer. I mentioned that earlier. They're certainly looking for multi-mission capability in a single platform without having to introduce new type model series into the fleet that require a different training system and a different maintenance system and a different set of MILCON that may come with that product. So what you'll see, at least from Lockheed Martin, is a heavier emphasis on international and adjacencies, a lot more focus on MRO and modification. That's all wrapped with kind of an affordability envelope as well. We're spending a lot of time and a lot of our discretionary investment in driving affordability into all of our programs right now, simply because those ACAT 1D programs, like a JSF or a very large capital equipment acquisition, just aren't out there. If you look out there, it's F-35, and then maybe next generation bomber, and then maybe some UAV programs. and a trainer program in the aviation world. So there's going to be a lot of competition for that. So right now, in addition to focusing on those other areas of our portfolio, focusing on affordability so we can win that business when it does arise is really important to us.
Thanks. Well, you brought up MRO, which will turn me back to the other side here, to the, I think, the largest MRO in North America, Delta Airlines. You talked about in your opening comments about the very diverse fleet you have now, and part of that is because of the recent merger with Northwest Airlines, which brought a lot of Airbus airplanes into the fleet that you didn't have before. Really, Delta traditionally had been a Boeing operator. So you have this very diverse fleet, and you have aircraft. You're buying new aircraft. You have a lot of legacy aircraft, the MD-88s that you've been operating for quite a long period of time. What are some of the real challenges you have there in terms of this very diverse fleet, lots of different ages in the fleet, and where are you going with that fleet?
That's a great question. You know, with respect to the MRO, it's a huge part of our technical operations division. It operates essentially as one of our standalone businesses, and the diverse fleet has been a benefit for us there because it's allowed us to obviously get into more products, more different fleet types and engine types that we can provide support for our customers. With respect to the diverse fleet that we have, again, it's sort of like the pilot training question that we talked about earlier. There's a challenge and there's also an opportunity. On the opportunity side, if you look at an airline, it's sort of like a rheostat. You know, you have the network planning group, the commercial side of the business, that's obviously focused on what our customers want, which is a very diverse flight schedule. We really operate a different schedule every day of the year. So the network wants flexibility and wants to be able to take advantage of opportunity. So there's a euphemism that developed around our fleet after the merger, where network began referring to our fleet, which had been really focused on operational efficiency and single manufacturer. Now we have the Goldilocks fleet. So network can have its choice of several different narrow-body aircraft and tailor that product to a specific market, even down to markets where, based on customer research, there may be a higher desire and some benefit to having in-flight entertainment versus a narrow body that doesn't have fixed in-flight entertainment on the aircraft. So it gets down to that level of detail. So that one end of the rheostat, that commercial end, wants flexibility and wants real close-in time planning horizons. The operation, of course, wants stability. You know, technical operations, our maintenance department wants to have touch time on the aircraft. They need to have enough time to work on the airplanes. We've got certain, periodic inspections and work that has to be done. So we want predictability. Pilots and flight attendants want to fly the same schedule all the time. They want to fly the schedule so they want consistency and predictability. So the question is, with the fleet that we now have, how do we provide the maximum value to our customer, but also sort of scale that back just enough so that we can run a reliable operation? So if you look at, I would say, if you look at the customer's needs, we have several key operational metrics. Completion factor, the number of flights that are being completed in a particular day. Obviously, on-time arrivals, on-time departures, and baggage performance. Those are probably our three, sort of 1A right behind safety, okay? But in terms of operational metrics, that's what we look at. If you go back to 2010, our completion factor was 98.5%. And at about 900,000 flights a year, that sounds like, pretty good performance. When you were in school, 98.5 was kind of an A+. But in the airline business, it's not good enough. And it actually is not how we have historically performed. So after the summer of 2010, we made some adjustments. Our Technical Operations Division, which in many respects is the foundation of the entire operation, because without an airplane that's ready to go at the gate at the time when we're ready to board the aircraft, if the airplane's not ready, then the agents can't board it, the ramp crews can't load it, the flight attendants can't get customers seated, get baggage, stored, provide customer service. The pilots are delayed in getting their pre-flight tasks done, and it just delays the operation, and it tends to cascade throughout the day. So after the summer of 2010, our Technical Operations Department implemented 11 initiatives during the succeeding shoulder seasons, really, of the fall and winter of 2010, early 2011. And one of the things that we did was we established some centers of excellence around our network, whereas if we had a problem aircraft, we would route it, for example, a 757. We concentrated our maintenance expertise and spare parts inventory in certain areas so that we could take care of problem aircraft. We put some parameters around our network planners, and we said, there's no reason in Greenville, Spartanburg to have, a 717, a 737, an MD-88, and an A319, laying overnight. And we had that happening in some parts of our network. So we generally, particularly at our spoke cities, we tried to concentrate on, let's get the aircraft routed to make sure that maintenance has a certain percentage of touch time on the aircraft so that we can give the airplane the attention that it needs. And what we found is, over the next 2 years, that our completion factor rose from 98.5% to last year 99.7%, with, again, pushing over 900,000 flights a year. Those statistics, when I talk to our employees about them, they're not necessarily tangible, they're just percentages. Like I said before, 98.5 is an A+, so is a 99.7. What's the big deal? Well, that's almost 12,000 fewer flight cancellations for a year. So multiply that by the number of customers that were not inconvenienced, the flights that were able to operate on time, our agents were not having to apologize to customers. We didn't have so many disruptions in the system. We're kind of narrowing the playing field to dealing with weather and other operational disruptions in the system. And we continue to operate to that level. As a matter of fact, I just looked at the metrics this morning. I believe our completion factor for this month is 99.92%. So, and we actually have, last year, I believe we had about 115 100% maintenance completion factor days in the system, and 72 days in the system as a whole, and we're running ahead of that rate this year. So our entire ops team is pulled together, but again, with that foundation of having, I think, an outstanding maintenance program, and also processes that have allowed us to collaborate with our network planners to make sure that we're able to take advantage of the diverse fleet that we have to provide the kind of product out there that our customers want and the kind of schedule that our customers want, but also to make sure that the airplanes are performing in a reliable fashion.
And you forgive me, a little personal anecdote here. I know the airline takes it very seriously. One stint I did at Delta Airlines, and you might relate to this, is that every morning there was a conference call every morning where they went over statistics for the previous day, and the very first thing was talked about were flight cancellations. Right. And the reason for the flight cancellation, sometimes it's maintenance, sometimes it might be technology, IT technology, various things. Well, if your organization was the reason for one of those flight cancellations, as the manager of that organization, you got invited to join the call. I'd been on the job about 2 weeks, and I was invited to join the call one morning. It was not an enjoyable experience. Came back to my group and said, look, we're not going to do this anymore. This wasn't fun. Because you had to come back the next day and tell them what you did to take care of this problem. So it's something that the airline takes very seriously, and glad to hear the recent statistics. And I want to really take the next question to both of you, and I do want, if as questions arise, don't wait. Just let us know. I will see you, and you have a question? You have lots of questions. Sandy has lots of questions. Well, Sandy, there's a mic right over there. All right. Well, the next question, airplanes have changed a lot over the last 50 years. Now we're having composite materials, we have all the digital avionics, we have all these things that are on the aircraft. We'll start with Jack and then go to Steve. How has this changed your business in terms of selling the aircraft, training people to build and maintain the aircraft with all these different technologies, especially composite materials, which is sort of the new thing, and maybe from the C-130J, you can talk about the digital avionics revolution in that airplane.
Sure. Well, from an avionics standpoint, I mean, the level of technology that you can integrate into the cockpit and even in the back end of the airplane in the cargo area has really revolutionized the air mobility world. I mean, we took this 60-year journey with the C-130 through the C-130A, the B, the E, the H model aircraft, and various commercial versions of the airplane too. And we took this kind of evolutionary step in terms of capability. When a technology or a capability kind of matured, we would put it on the airplane until the mid-90s, and we took kind of a revolutionary approach and digitized the aircraft. So what did that do? For the pilots, that gave them a level of situational awareness in the cockpit that was unprecedented in a mobility aircraft. A level of integration through the mission computer just simplified all of the tasks to the point where it allowed us to eliminate the navigator and the flight engineer, and it was all running on the computer. Right? So both the left and the right seat in the airplane are both pilots. There's a pilot in command. There's no pilot co-pilot anymore. So it fundamentally changed the way the ConOps were generated in the airplane. From a manufacturing standpoint, the technologies, specifically in composites, save a whole lot of weight, and especially on a fighter aircraft, weight is a paramount concern. So both the F-35 and the F-22 are about 30% composite materials, and even on the C-130 we've introduced some composite control surfaces and that type of thing. Not only are those composites a little bit more durable to corrosion and some of the environmental aspects or environments that those aircraft operate in, but they're lighter and they're stronger than aluminum as well. The training to work on those materials, I mean, we're already there. What we're seeing in some of the new resins now is, and it's one of the limitations of composites, especially very large structures, is finding an autoclave that's big enough that can house the component where you need pressure and heat to cook the component. We're seeing in some of the advanced resins now that you can make those components simply through temperature, and you don't need that pressure capability. So as those things advance, we're learning how to use those composites in a different way. One of the things that is really interesting is, from a manufacturing standpoint, is additive manufacturing and 3D printing. Right now, we've got about 45 additive manufacturing printers in the corporation, all but across all of the AM technologies, but all but one are really, one of them is really a production type of machine. It's in the space systems. But that's enabling us to build prototypes of parts and aerodynamic models for wind tunnel testing, where we used to use stereolithography. We can do it very fast. We can make tools for assembly and drilling very quickly and insert metal bushings, and we can have a tool overnight. So some of those new technologies are really facilitating a new way of looking at how we manufacture. It hasn't really become common practice yet, the additive manufacturing part of it, but it offers a lot of promise,
How about from the operator and maintainer point of view?
Well, from an operational perspective, as Jack said, to the extent that composites, are lighter and more durable, they'll add mission capability to the aircraft. So I referred to our network planning department earlier. You know, one of the first things that our network planners look at is what's the range capability of the aircraft, and we tend to work from the most capable down to the shortest range aircraft when we plan our city pairs. We try to maximize the utilization. So, for example, you know, we really wouldn't want to fly a 777 aircraft, although we did it at one point in our history between Atlanta and Orlando. We would rather fly it from Atlanta to Johannesburg or Los Angeles to Sydney. And so to the extent that the introduction of, or the use of composites for a manufacturer allows us to push the airplane harder, operate more efficiently from a fuel planning and a flight planning perspective, there's a big operational benefit. Something that you might not think about, it does affect how we paint airplanes. Because, and you can look at American Airlines as an example of this, I think something that drove their new livery is the fact that American traditionally had done a polished, shiny metal fuselage, and if you're having more and more composites introduced at some point, you're not going to be able to keep that same paint scheme, and so they've adapted to you know, a paint scheme that's different from what they've had historically. We used to polish the bellies of our aircraft, and you know, now we actually have a livery that we've had for the last 7 or 8 years where the entire aircraft is now painted. Now, I'm not saying that composites drove that decision, but it's something that can affect something as mundane as the paint scheme on the aircraft. In terms of you know, repairs in the operation, obviously there are you know, different processes that have to be used, but we've got a good bit of experience, and one of the core metrics that we look at, again, on our top 5 or 6 safety metrics, one of the things that we look at are ground damages, and that's part of that, you know, daily report that goes in as, you know, where are we seeing ground damages at our stations around the system, and something that's on the station manager's or hub scorecard is how they're performing in terms of ground damages. So we have a big focus on that, whether the airplane is composite or not, because obviously we don't want to have to deal with that. I do have a couple of my tech ops colleagues here, Bob Gleason and Al Hegner, and I don't know if you guys have anything you'd like to add from the maintainer perspective, but I don't think that you know, there's really anything other than you know, more efficient materials for certain applications and efficiency and weight really that's been a benefit to us. Do you guys have any comments?
I would agree. The fundamentals of composite remain. It's the technology and the risk of life. That's what Hello, hi, I'm Al from Delta Tech Ops. So for composite repairs, you know, like Jack spoke about earlier, the technology and the resins, you know, that's the areas that we're focusing on right now. The overall fundamentals of composite repairs remain the same today, and it depends on if you have an autoclave the size, you know, to fit certain panels in and so forth. And we found at times at Delta Tech Ops where we are, you know, actually more advanced in the manufacturer itself in designing tooling and the size of our autoclave within our system. So the focus is on the resin and the mixture and how fast we can, you know, get it going, how fast we can perform the repairs on our aircraft. But other than that, we haven't seen any setbacks in the composite area for our aircraft types.
Thanks, Al.
Okay, and we had a question from a young lady here.
Yeah, actually, this is fascinating. I have questions for both of you, but I'll start with Steve and then give someone else a chance. And if they're too shy, then I'll ask my question for Jack. This has been really interesting to get under the hood a little bit and see what happens or listen to what happens in the airline industry. And I'm actually very impressed by your completion statistics. That's incredible. And that the general person who flies does not understand all the complexity of the systems and the logistics and the systems engineering that's happening underneath the hood, as it were. And so it's just, I could probably talk to you for hours just about the logistics. I'm sort of a logistics person. But the question I have for you is, you were talking about the next gen, and I see that as the same level of complexity. There is the system we have now, and we're trying to introduce new aspects of a air traffic control community and to the community. And so it's kind of a social engineering problem at the same time that it's a technical systems engineering problem. And so I'm curious which one's leading and which one's trailing, and how are you, as you guys figure out how to introduce different elements, how are you deciding what elements to introduce at what rate? And then, of course, you have to work on the law of unintended consequences. So this is a fascinating problem. If you could share some of the stories or the approaches that the group is taking, I think that would be very interesting.
Sure. No, it's a great question. And I think that the short answer to the question is that the introduction of technology in the form of tools, for example, something like GPS on aircraft, or even advanced surveillance that are replacing air traffic controller radars, that's generally happening at a faster pace than the associated policies, procedures, change management, training, all of those kind of things. And that's been very frustrating for the operator community in particular, not just airlines, by the way, business aviation, general aviation, military. And, there's the whole UAS issue that the FAA has not really grappled with yet. So we've got Amazon out there talking about, delivering packages, but how is that, we're all swimming in the same ocean, we're all flying in the same airspace, so how is all this going to fit together? And those are the answers that we don't have. A couple of one local example in particular, I referred to Atlanta is obviously the world's largest and busiest airport. And but it actually presents some opportunities to develop some of these advanced procedures, because we have a completely parallel runway configuration, unlike some other airports in Houston, for example, where you have crossing runways. Chicago, you have the Midway Airport, that's close by. Same thing in Houston with Hobby. Southern California, you have many airports in close proximity. So even though it's the busiest airport in the world, there's a certain there are certain aspects of the aviation environment here that we should be able to take advantage of. And when you measure the benefit of a new flight procedure, excuse me, for example, what we call an optimum profile descent, where instead of getting altitude clearances, sort of step down altitude clearances, you get a descend via clearance where the pilots from 35 or 40,000 feet will essentially, it's like you get on a banister of a stairway, and just slide down to the bottom, and you're in the traffic pattern. We're in the process of designing those new types of procedures, and you can measure that benefit in terms of fuel savings. And we call them optimum profile descents, and the test procedures that have been developed for Atlanta save us probably 400 to 500 pounds of fuel per flight. Tremendous environmental benefits, economic benefits. It's also much more predictable and reliable for the customer, which again will help out that baggage performance, completion factor, everything else, because we can manage our gates, we can manage our taxi-ins, we just have better data on which to run the operation. And these procedures are designed to connect to really a turn to downwind and then turn to final approach that's a defined flight path. So it takes a lot of variability out of the system. The problem is our current ATC controllers are very good. I mean, they're outstanding, and they're really the best in the world. And what we have now is on the conventional arrivals, they're actually able to absorb, sort of be a shock absorber in the approach as we approach the airport. So what will happen is there's more arrival demand. Airplanes are coming in, and they're not coming in from just one direction, by the way. They're coming in generally from 4 corner posts that are about 40 miles out, northeast, southeast, southwest, and northwest. And so what the air traffic controllers do is, as there's more and more demand put on the airport to get the peak throughput of the airport, there's this trombone phenomenon that develops, where as they vector airplanes in, the final will get longer and longer and longer, but what they're essentially doing is absorbing inefficiencies that otherwise would propagate out into the en route airspace. So what's happening is that as we have more precise flight technologies on the flight deck, and we can fly very precise flight paths, if we don't have the integrated air traffic management merging and spacing tools for the terminal environment, because remember, we're taking away speed control and vectoring of aircraft from the controllers because we want to fly that defined path all the way into the runway. Well, what ends up happening is the adjacent air traffic control facilities end up propagating delays and putting buffers in that can actually go back to the originating airport. And so what we found is when we've turned on some of these new procedures, we actually have seen ground delays at places like Indianapolis of 30 or 40 minutes waiting to get into the overhead stream because air traffic control, this is a change for them. The en route controllers are putting in more miles in trail because of this defined tighter flight path. And so what we need are again, integrated decision support tools in the ground system that allow us to run a smarter system so that we can leverage some of the avionics that's been put on the flight deck. So that's where I get into, you know, when you're putting an advanced navigation system to get into a mountainous airport and you want to fly a really precise flight path, that's a great application. But when you try to take that same technology and apply it to a system at a major hub, particularly in the eastern part of the U.S., or in a place like Southern California where you have a lot of ATC congestion, there's a lot of other enablers and elements that have to go along with that. And so you take again, you're going to hear from Ed Bolton, who's a retired two-star Air Force general, who's the Associate Administrator of NextGen. He has to take the programs that he's developing and essentially operationally implement them into a part of the FAA that isn't under his control. So you have the safety organization part of the FAA that has to do safety analysis that tends to take, you know, years to get done. And so you've got technologies that are ready to be fielded, but the actual use of them to benefit the customers and also so that I can get the return on investment for my business case, you know, it's a tough nut to crack. And so that's what we're really, you know, we tend to put ourselves in the shoes of the traveling public. We're not looking for technology for technology's sake. What we're looking for is improved operational capability. How is that going to improve my completion factor? How is it going to improve my on-time performance? How is it going to allow me to take block time out of the system and operate more efficiently? When we can show those kinds of metrics, you know, then we'll be much more on the same page.
Okay. You have a question, Rich?
Yes. Well, so you touched on what I was going to ask about, but Delta, large aircraft, how do you view the whole UAS and the NAS discussion that's going on, and how does that impact Delta flying into large airports? Is that a daily discussion or something that you're just kind of watching?
UAS is not something that we are seeing a lot of. You know, we're still in the very early stages, and again, the FAA has not decided completely how to manage UAS systems in the airspace. But it is something that certainly, you know, even if you're transitioning on a military application back and forth to a training area, you're still transiting, you know, civilian airspace as you do that. So it is something that is going to be an ever evolving and actually increasing issue of importance. And you know, it's going to be something that we're going to have to deal with as part of the system, just as we do with general aviation, business aviation. This is not an airline-only discussion. We've got other operators out there that we need to be able to account for.
Okay, I think we had another question back here.
Yeah, good morning, thank you. I guess this question is for both Lockheed Martin and the airline industry. You've touched upon a number of things that are very wide in terms of the tasks that you are involved in, so anywhere between customer service and coatings for aircraft. Now, when you start dealing with tighter and tighter budgets and increased competition, everyone's pockets are a little bit emptier these days. What things do you have to put at the bottom of the list, and what things do you make a priority and therefore become sort of critical missions that you have to meet?
Okay. Jack?
So the days of a good idea that's not performing well are probably over, okay? Those type of programs are not only going to not enjoy any priority from the customer set, whether it's the U.S. government or an international government, they're probably going to get canceled. So the focus has to be on performing on the programs you have and meeting your commitments to either your contractor or your customer. So we put a lot of emphasis on meeting our commitments, and it's not just our financial commitments to the corporation, it's our contractual commitments to the customer, so that the program that we're executing on enjoys a level of support in the process. So I would say from a priority standpoint, how do we prioritize things? Those things that are a good idea but aren't performing are probably not going to get a whole lot of attention or priority. Those things that are critically important to our mission and our customer and our shareholders as well, frankly, are going to get a lot of priority and are going to get a lot of attention in terms of performance and meeting commitments.
So I'll just use NextGen and the NextGen Advisory Committee as an example of setting priorities. The NextGen Advisory Committee is a federal advisory committee, and it is set up under the auspices of RTCA in Washington, and I've been involved with it for several years. And one of the good things about the RTCA process is it provides a way for industry to come together and work with the FAA subject matter experts, but be outside the government and provide industry priorities to the government to develop these operational capabilities that I've been talking about. Because the FAA tends to think in programmatic terms. And those programs, if they don't translate into operational capabilities that benefit our customer or our stakeholders in some ways, whether it's communities or our operational metrics, but ultimately our customers, then it's not really something that we're interested in investing in. So we realize that there are foundational technologies that have to roll out, but when we're making investment decisions on retrofitting aircraft avionics, for example, that has to have a certain return on investment. And the problem that we've had more often than not is that we've made investments and the system, the operational improvements are not really within our control, as we're relying on the government to execute, often it's policies and procedures implementation. So one thing that the NextGen Advisory Committee has done is take, about 150 or so FAA operational improvements that are defined in the NextGen implementation plan and translate them into the 4 most important operational capabilities. And we said, let's make some significant progress on these within the next 3 years. And those are broader implementation of performance-based navigation, progress on multiple runway operations. For example, you have certain airports that are constrained either through crossing runways or airports that were built that are operationally constrained because the airplanes were built with very close lateral separation from each other. San Francisco is probably the most prominent example of this. And the rules have never been rewritten to take advantage of the improved navigational capabilities that exist in the system today. So we're losing some capacity and some benefit there. Surface traffic management is the third area. This is an area where The FAA measures its success, the success of the system in certain ways. Our airlines and frankly our customers measure it differently. You know, many of the delays that happen in the ramp area, the non-movement area, the FAA doesn't measure that, you know, in the Bureau of Transportation Statistics. So we have to share data, but, you know, down to, again, that departure from the gate and the arrival at the gate at the next destination. And the fourth area is the implementation of basic data communications. Again, that text messaging that I talked about earlier for revised departure clearances for pilots. There are a whole slew of capabilities that are planned for the next decade on that. But we've had difficulty in taking some of the things that we've been doing in the oceanic environment and applying them to the higher density domestic environment. And so we're setting some priorities there to implement 2 or 3 basic capabilities for the next 3 years. And so I think in terms of priorities, what that's informing the FAA leadership to do is to go back and look at, you know, how they're prioritizing certain projects and certain enablers, because they know that that's what the traveling public is looking for.
I think we had another question back there.
Yeah, hi. Really appreciate the discussion. It's been very wide and focused on a lot of aspects of aviation. One that you haven't touched on yet that I know there are some companies here that are interested in, and that is the future in supersonic flight. Are there some possibilities, is there something in the next 20 years that might come up that says there's a business case for operations for commercial flight and we've overcome supersonic overland challenges, taking some of the military technology perhaps and translating that into more efficient flight there, and then the whole next-gen operations adds another complexity. What are your perspectives on that?
Well, let's start on the manufacturer side, because I know Lockheed, the Skunk Works, has done a lot of work in low boom supersonic flight. I don't know if you can talk a little bit about that.
A little bit out of my swim lane, but we're as an aeronautics company, and as specifically as Stephen said in the Skunk Works, we're very interested in supersonic flight and the acoustics associated with supersonic flight over the national airspace, over land and populated areas. So I know we have been doing a lot of research on how do you control that sonic boom, how do you manage it, how do you shape it for a commercial application. So those are some of the things that we're looking at. Obviously, we're not in the commercial aircraft business per se, other than the LM-100J that we recently launched. That's a natural progression, but we are interested in some of the technologies that would accompany a supersonic type of a vehicle in a commercial application. So we have been looking at the propulsion side of that.
And how about from the operator perspective? Does supersonic make sense, even in the commercial environment?
I mean,
today?
you know, if you look at what's happened over the last 20, 25 years, you know, certainly currently there's not a platform out there that makes sense. I think if you talk to Richard Branson at Virgin, you know, he's getting into Virgin Galactic and all that. So there's definitely some out there who feel that there is a market for for space travel and maybe supersonic at some point. But I think it's going to be pretty far out into the future, and it doesn't seem like. Certainly if you look at the major manufacturers, Boeing and Airbus, there's nothing on the drawing board that I see that's going to result in a commercial application on any broad scale for supersonic transport.
Okay. Yes, ma'am.
It's me again. Even though we could go, I know I could come up with a million more questions about next gen, and I probably will later when I talk to you. Jack, I wanted to address a question to you that is a very prevalent theme in the industry from a workforce viewpoint, because you touched on this a little bit in your opening comments. You know, we talked about the fact that the design process and the cycle for a program is becoming so long. So there's some concern about what that's going to do to our workforce experience base, because you don't have the quick turns, you don't have an engineering and a technology workforce that can go from initiation to production and even into the operations, because those are all different types of engineering approaches that you have to take. And so we're losing a little bit of that. And when you consider the next generation fighter might be decades away, you're basically starting from scratch again without some corporate knowledge of the program going through the program of the record today. So I was wondering what Lockheed was doing to try and preserve some of that corporate knowledge or preserve some of that workforce skill set, either in training up new guys or holding on to the old guys, or balancing our internal research and development with contracted research and development, because it's a really big problem, and it's actually occurring all over the industry, and I'd love to hear your approach.
That's a good question. There's a problem on the front end and the back end. So we talked a little bit earlier about, Orlando touched on it in his opening remarks, about the importance of recruitment, STEM education, down to and beyond the high school level, in terms of internships and getting that type of capability in on the bottom end. I don't think our demographics are much different than Delta's in terms of pending retirements and the influx of new talent. So we're addressing it on the front end, through those type of avenues. On the back end, I'll give you a real world example of one of the things that I've been advocating. We're in the process, and the program of record is for 52 C5Ms. They're going to take 52 of the best C5s and convert them through the AMP and the RERP program to C5Ms. We have a workforce that is working on that project in a level of detail that we never expected, because when you open up an airplane, you find out all kinds of things about the airplane that have been in creation for the 20 or 30 years it's been operating. So we're generating a whole lot of expertise on this very small fleet, a national asset of C5Ms, 52 aircraft. The program will start ending in 2016, and the ownership of that program will then go to the depot, in this case Warner Robins. But what do you do with all that expertise that you've generated at the company level, honestly, at the company level, when you turn it over to the depot? You got to figure out how to transition some of that knowledge in the process. Otherwise, it's an investment that's wasted, right? So what I've been advocating is let's think about this fleet, and it's a very small specialized fleet, in terms of a national asset, and think strategically about how we transfer knowledge in this process. And we could throw it over the fence into Warner Robins and we wouldn't transfer any knowledge unless they came and asked for it. Or we can approach the depot and say, how can we partner in this process and provide you with the knowledge we've gained and all the tools we've gained, all the laboratories and whatnot that we've generated over the performance period, and utilize that in a partnership to make the operation and maintenance and sustainment of that national asset more efficient. So that's a real world example of what I'm trying to advocate right now to my Air Force customer and the depot is, hey, you got a talent pool right here that is going to be wasted if we don't think strategically. So let's start that dialogue now, not when the program's ended and all those people have gone to find other jobs and we can't get them back. So that's a real world example of what you're talking about.
Okay. Well, thank you for the transition, because that's a question I wanted to pose really to both of you, and I'll kind of lead into it this way. The two companies we have here have some similarities from the point of view of we're keeping aircraft in service, and aircraft programs are lasting much longer. I'll kind of pick on Delta to start with. Delta was the launch customer for the DC-9 in 1965. Well, here we are 50 years later, and you still are operating the latest versions that come, the MD-88s and the 717, which are really the MD-95. Let's say you go another 10 years with the MD-95. That's a 60-year program from the operator perspective of an aircraft. That's something I don't think anyone ever anticipated. I know Delta probably didn't anticipate a 60-year program with this aircraft type and that type certificate back then. Now, to pick on Lockheed Martin, turn to them. The C-130, about to celebrate 60 years of production since the first flight of the C-130. You've talked about production is still continuing. for, well, let's say at least another decade. I'll say that, you don't have to nod your head, but let's say it goes another decade. So that's 70 years of production of this aircraft, and would that final aircraft stay in service 20, 30 years? C-130. So you're talking about a 100-year aircraft program. This is for an aircraft with Kelly Johnson, as I've read, thought they'd sell a handful of at the time. It was maybe just going to be a small little program. It becomes a 100-year program. So now we have programs on the operator and maintainer side of 50, 60 years of operating a type of aircraft, various versions of it, a 100-year aircraft program on the manufacturer side of maintaining that. Those are spans that are well beyond the normal work span of, most of us work 30, 40 years and retire, hopefully. Now we're talking about 60 to 100-year programs, well beyond an individual. You could see individuals could work on a certain aircraft type for their whole career, retire, hand it off to the next guy, and that person could be well into their career and maybe finish their career. What kind of special challenges from your workforce perspective, and even from a technology and engineering point of view, does that present to you? And we'll start on the Delta side.
Well, thanks, Steve. So there's, obviously we are, when we talk about aircraft programs like, the DC-9-10 in 1965 versus the 717, we're operating the airplanes generally for our McDonnell Douglas and Boeing fleets. Generally, we plan on about a 30-year lifespan for the airframe, and of course, spares, engine spares. Obviously different engine types. You're operating newer variants, so it's not a matter of maintaining an airframe or an airframe engine combination, as the Air Force might have had to do with the KC-135 for that many years. But certainly there are opportunities when we look at our cost to operate. Fuel is our largest operating cost. So in that sense, a newer aircraft is attractive, but we found that we don't really want to be on the bleeding edge of technology. That a mature airframe generally fits into our fleet strategy very well. And when you combine fuel costs with ownership cost, that makes an airplane like an MD-8, MD-90, or 717 actually very competitive. And so we actually look at for certain markets, that's actually the best fit for our customers. Now we have to, maintain, top quality cabins. We have to have programs that will support those airplanes. And as you get into aging aircraft issues, you may have to stock some additional inventory and those kind of things. And again, concentrate maintenance expertise and inventory in certain locations to make sure that you can still get the same levels of operational reliability. We actually get we survey our customers on a number of attributes. We hear back from about 10 to 15% of our customers, and they actually rate some of our older aircraft types higher than some of the newer ones in some cases. So it really is about customer service, about the physical product, about how well the airplane is maintained, that we found that really makes the difference. Of course, as we look at, wide bodies are a little bit different in the sense that the operation tends to be more brittle internationally, because generally you're doing more point-to-point flying, and you're at the sort of on the frontier of the network in some cases. So unless we're flying into one of our big international hubs, if we're flying into Shanghai, for example, we may only have 1 or 2 flights a day in there, so we've got limited infrastructure to be able to recover the operation. So for wide bodies, we'll generally put a higher premium, and we're less able as a system to deal with some of those aging aircraft issues. So the calculus changes a little bit depending on the nature of the operation. In the domestic system, you've actually got a lot of opportunities, again, to get touch time on the aircraft, and if you do have a disruption or a delay, you've got multiple ways to reaccommodate customers that don't exist in the international realm. So that's how those two sides of the fleet really fit together.
Okay. What about the 100-year, potentially 100-year C-130 program? What's the challenges there? I mean, you talked a little bit about the J, but
Well, I'll start off by saying I am unashamed of the success of the program. The longevity of the C-130 is not only a testament to the design, the original design point, but the ability of the aircraft to adapt to technologies and capabilities that were needed. So going forward, the key to the longevity of the program into the 100-year realm is maintaining its relevancy from a technical perspective and operational perspective, but also addressing the affordability issue. And I'm not just talking about acquisition costs, I'm talking about operations and maintenance costs as well. So one of the things that we are benefiting from in the launch of the LM-100J is we've had to take a hard look at how we maintain that airplane, because for a commercial operator, it's not about national mission accomplishment, it's the bottom line. And that has forced us to look at different maintenance techniques and spans between inspections and what makes sense in a commercial environment that, you know, if we're successful, we're going to port that over into the military environment as well, instead of strictly operating by mil standards and mil specs and STANAGs in Europe and those type of things. Some of our customers are making us look at things like DO-178B compliance for avionics and software. You know, if we can figure that out, we'll probably start blending a little bit more commerciality into our not only business practices, but into the platform itself. So maintaining the relevance of the aircraft technically and operationally and addressing affordability as we go is going to be the key to the longevity of the program. If you look at the history of the program in the 60 years, the cost of the aircraft has only gone up about 2% per annum over the life of the program, whereas the capability's gone up tenfold in the process. So far we've done a pretty good job of managing it, but we've never experienced this type of economic environment that we're currently facing or in right now. So we're going to have to look at things differently, and we are.
okay. I will point out that the original L-100 was operated by Delta Airlines, so maybe you two should talk afterwards a little bit. I think we have another question here.
Yeah, really good discussion, so I appreciate being able to sit here and listen. One thought of companies compete against each other, and they also collaborate. And how do you, Delta and Lockheed, juggle that? Because sometimes you're competing for a big program, sometimes you're partnering with others on a program. In the next gen, I guess, is going to be a lot of collaboration because it's going to affect both defense and the commercial, and everybody's involved in it, but yet, you know, American Airlines and Delta compete for passenger seats. So if you could talk about that a little bit.
Sure, a great question. I think probably would answer it in two ways. First is on aviation safety. There is no competitive aspect to that, in my view. We are, you know, all the operators in the system through the commercial aviation safety team and various voluntary safety programs that we participate in, along with other carriers and other operators in the system, even sharing safety data and event reports with the air traffic control system versus how, you know, an air traffic controller saw a certain situation versus a pilot. You know, those are very important to allow us to learn, and I think they've contributed to the safety of the system that we enjoy today and where we keep trying to raise the bar. So there are a number of ways that not only the carriers but also the FAA and other federal agencies and other operators and manufacturers collaborate. So I'm involved in several different venues where that happens. With respect to improving the performance of the system, I'll give you one example. I was actually the chairman of the Next Gen Implementation Task Force back in 2009. And we had over 300 participants from every segment of the aviation industry. So the airlines are actually a very small piece of that, even though we tend to be the heaviest users of the system. And we certainly have reporting requirements, you know, the Department of Transportation that exceed any other industry that I'm aware of out there. So, you know, my charter was to lead this and produce some recommendations, some implementation recommendations for the FAA on behalf of the aviation industry, not the airlines. So what that meant in Delta's case is that, you know, we couldn't look for, you know, 100% Delta solution or 100% airline solution even. We had to accommodate the interests of general aviation, business aviation, military, and frankly the manufacturers, because even though we find ourselves sometime in commercial negotiations on the other side of the table when we're considering, you know, retrofit of systems or acquisition of new aircraft or components, you know, ultimately they have businesses they have to run as well. So all of this has to be taken into account. And, you know, I'm very proud of the work that that group did. And, you know, I've always felt like, you know, it's kind of the old adage, perfect is the enemy of good. And, you know, a good plan that's flawlessly executed is much better than a, you know, a perfect plan that's never executed. So, you know, we're trying to keep everyone moving forward in a collaborative fashion. And again, I think that we've made some progress. There's a lot of opportunity to make quite a bit more progress. And collaboration is a little bit messy. But again, I think if we keep the dialogue going and we understand, you know, the target that we're shooting for and the paradigm shift that we're trying to achieve, you know, we will get there. And you know, from my perspective, what I have to make the FAA and sometimes the manufacturers understand is a big key is making sure that we get benefit out of existing equipage and technology that's in the system. Sometimes a manufacturer will hear that and they'll say, well, Delta doesn't want to buy anything new. Well, nothing could be further from the truth. But the fact of the matter is, it helps me make the business case for that new piece of equipment if I can go back and show my leadership, my shareholders, the benefit, the operational benefit and the customer service benefit that we've been able to gain from decisions that we've already been made. So it's a little bit of a chicken and egg discussion, but you can keep that collaboration alive if you make sure that, you know, we understand, the operators understand what the manufacturers need to do, what the government needs to do, and they understand how things look sort of from the other end of the telescope and also from the perspective of the traveling public.
Jack?
So, you know, teams can either evolve or they can be picked. And I think in our recent history, there's been examples of both of those. Stephen Justison had mentioned earlier that those large programs or opportunities are few and far in between going forward. So if you want to bid on those programs and win, you better go with your best team. So a lot of times we take the best athlete approach when we're choosing teammates and strategic sources. The JSF is a good example of that. Since the Last Supper, there's few choices to make in terms of companies. However, there's a lot of capability out there. And for instance, on aircraft carrier type environments, there was only a couple of companies that had that type of experience in the United States, and that was Northrop Grumman and McDonnell Douglas, eventually purchased by Boeing, right? So you go to the best athlete for capability in some cases, and those are the type of decisions that we have to make sometimes. We go through a very deliberate process of making those decisions, and it takes a long time. I was looking on some of the sponsors, you know, that are up on this board and on the prompter down there. You know, we have partnerships in some form or another with all of those competitors, and that makes us, we call them competimates, right? But those athletes are out there, and you have to choose those capabilities when you want to pursue something or if you need to get something done. So there was a book written several years ago called Now Discover Your Strengths, and the whole thesis of that book is that at this point in your career and at this point in the history of Lockheed Martin, we know what we do well and we know what we don't do well. And the trick to success is surrounding yourselves with those people that do those things well that you don't. So that's kind of the approach you have to take sometimes.
Okay, great. I think we had another question back there.
I've got the mic, so I must be the questioner. Stephen, you mentioned about 100-year programs that triggered something in my mind. We're about to celebrate the 100-year anniversary of NACA, predecessor to NASA. And so my question is focused on the trend in R&D funding, federal R&D funding in particular, and what impact or influence that you think that has had leading up to this point, and recognizing that both defense and NASA, FAA R&D funding has been on the decline in the past decade, and what that may lead to in terms of the pipeline of technologies for future beyond next gen or new aircraft systems.
Start with Lockheed on that one.
I would say in general, the R&D budgets and the availability of funding to support the labs and the labs going out into industry for solutions is probably going to parallel the type of things that we're seeing in the budget environment in general. So that brings me back to the importance of making sure that our discretionary resource investment plan is closely aligned with where our largest customer, the U.S. government, wants to go. So it doesn't make any sense for us to go off and invest in a left-handed hyphodeucinator when they're worried about a Klingon cloaking device. So it's prudent for us as an enterprise to coordinate and communicate. And someone asked a question, about how we prioritize, and I gave a very tactical answer. And probably a more strategic answer is, we've got something called Next Gen LM that is really a strategic framework that the cornerstone of it is communicating with our customer. And when I say communicating, I'm not talking about transmit, really listening. And I think, in the environment we're in, whether it's in a research environment or a production environment or a sustainment environment, us hearing where our primary customers want to go and aligning ourselves with that is probably prudent in the environment we're in right now.
Okay, excellent. We're just getting into the last few minutes of our panel today. So before we let these two gentlemen go, I want to give them a chance to have the final word and to touch on anything that we haven't. We've had quite a wide-ranging conversation. I think before the panel we were thinking, how could we fill 2 hours? And here we are just a few minutes away from 2 hours. And it has not been boring in the least, at least from my perspective up here. So give you the last word. We'll start with Delta. And what would you like them to walk away with?
Well, again, thanks for AIAA's hospitality, and appreciate the opportunity to share this time with you. I actually want to pick up a little bit on the STEM education issue from earlier. I do think that the airlines and our larger defense manufacturers in many ways are faced with some of the same demographic issues, whether it's pilots, engineers, maintenance technicians, analysts. We really need to work hard in this country to make sure that our base doesn't erode. And just in the case of pilots, as an example, since that's the area I'm most familiar with, we're certainly not seeing a shortage at Delta Airlines, but the industry is changing. And to the extent that we can encourage young people to come into technical disciplines, and that this is a great industry to be in. That's what I think is really good about forums like this, is the opportunity for folks who are earlier in their career to kind of really leverage some opportunities to really see what's going on. And we have some very strong partnerships with aviation programs at Embry-Riddle and Southern Illinois, and of course the University of North Dakota, other places around the country, because we think it's the viability and the vitality of the airline industry is a key national resource. In fact, I was at met with the leadership of U.S. Transportation Command last week. Delta is one of the largest Civil Reserve air fleet carriers, and most of our strategic airlift in wartime is actually in the three big network carriers. So it's a national asset that we need to make sure that we preserve and protect and nurture, and it's also a huge part of our economy. So I think that although we're certainly not, certainly private businesses, and we have our day-to-day competitive goals that we're trying to achieve and trying to put that product out there for the traveling public, there's a tremendous contribution by the airline industry to the commerce of the United States that needs to be considered in national policy circles. So again, just really appreciate your hospitality and the time together this morning.
And we're very pleased in Georgia that Middle Georgia State College, which is our main aviation school in the state of Georgia, is joining the Delta ExpressJet airline pilot pipeline program. So we're really excited about that here in the state. Jack?
I just want to echo Steve's comment about the hospitality of AIAA. Really appreciate the opportunity. Obviously, Lockheed Martin values the relationship and the membership in AIAA, so we appreciate the opportunity to participate. I guess I would just leave you with kind of a thought, and the thought is, if you think about kind of aviation history and how we, during World War II, flew bombers at high altitude, and then we discovered that you can also use low altitude to approach targets and prosecute. That led to advances in AAA and surface-to-air technology, which fed the whole EW community, electronic warfare, which created the whole technology known now as stealth technology. And those were all game changers. And there's a game changer out there. I mean, when you can compromise a very well thought out national priority mission that's accompanied by a presidential directive with a cell phone, there's technology out there that's being generated, even in this physically austere environment we find ourselves in, that are going to change the game in the future. So my question is what is that? It's out there, but I don't know what it is yet.
Well, as we finish today's panel, the AIAA has made available for us a small token for each of our panelists, a small medallion.
Thanks, Steve. Appreciate it. Thanks so much. Good to see you.
And next to each of you, if you look on your tables and pick that book up, it was not just decoration, but as a part of, from Georgia, we want to give you Georgia Flight, A History of Aviation in Georgia, 1907 to 2007, which puts a little more detail on that story I told you at the beginning about the history of aviation and the leading role of these two companies in that history. So please give them a round of applause. Thank you for being here this morning. The next panel will be at 2 p.m. today, entitled Transformative Aerospace System Analysis, Design, and Certification, A Vision for CFD in 2030. So please don't miss that. I think also we have is the tour still set for Wednesday, Amy? Is that? All right. So as you heard earlier, that Delta is celebrating its 85th anniversary of its first commercial service, and they're reopening their newly refurbished Air Museum down at Atlanta Airport. We have arranged for a tour of that. So if you're interested in seeing that bit of Georgia aviation history, it's a great exhibit, lots of aircraft in there, including a 767 and a bunch of other historical aircraft. Please see the registration desk where you can sign up for that. Thank you so much for being here, and have a great week. Thank you.
Thanks, Steve.
Thank you so much. Appreciate it.